students, in the previous lecture, we have understood that integration is the reverse process of differentiation. We have also done few methods to solve the integrals. We have done inspection method and we have also done substitution method. Now, today we are going to discuss the integrals based on some standard integrals. These are some standard integrals which can be easily solved or which can be easily proved using some standard substitutions. Now, we'll try to solve some problems based on these standard integrals. 1 upon x square minus a square dx. Now we can easily compare this with the standard form, that is 1 upon x square minus 4 square is comparable with the standard form 1 upon x square minus a square. So we can easily see that a in this case is 4. So applying the standard formula, we can write 1 upon 2a, a is 4, log of mod x minus a upon x plus a plus c. So this is the answer. Now we can take some more examples based on some standard integrals. So let us take dx upon 25 minus x square. So you can see this can be comparable. This can be compared with the standard integral dx upon a square minus x square, where a can be written as 5. So the answer will be 1 upon 2a, where 2 into 5 log of mod a plus x, that is 5 plus x, upon 5 minus x plus c, that is equal to 1 by 10 log mod 5 plus x upon 5 minus x plus c. Also in the previous question we can see that 2 into 4 is 8. So the standard integral can be applied in both these questions. Now let us take some more examples. We have dx upon 9 plus x square. This is standard form dx upon a square plus x square, which can be written as dx upon 3 square plus x square. While comparing with the standard form, a can be easily seen as 3. So the answer would be 1 by a, 1 by 3, because a is 3, 1 by a tan inverse x by a plus c. So this would be the required answer. So let us take one more example. If we have dx upon under root x square minus 16. Now we have under root here, so we will apply the standard formula dx upon x square minus a square, which is equal to dx upon under root x square minus 4 square. Now we can see that a here is 4. So applying the standard formula, we get the integral as log of mod x plus under root x square minus a square, which will be 4 square, which is equal to 16 plus c. Now in the next problem, we'll compare one more standard form, which is under root a square minus x square in the denominator. We have dx upon a square minus x square. In this case, we can take one example here, that dx upon under root 16 minus x square. Now we have the standard formula here, and that is equal to sine inverse x by a. We have the standard formula sine inverse x by a plus c. Now a can be compared here by 4, because 16 is 4 square. So the answer would be sine inverse x by 4 plus c. Now in this form, we can see that dx upon under root x square plus a square is the comparable form for this question. So we'll complete this square root as under root x square plus 7 square. Now a can be easily compared as 7. So we can apply the standard formula to get the final result as log of x plus under root x square plus a square. So let us take one more example. We have dx by under root x square plus 49, which can be easily compared with the standard form dx by under root x square plus a square. So let us transform this into the standard form. This under root x square plus 49 can be written as 7 square. So a can be compared as 7. Now the answer will be log of mod x plus under root x square plus 7 square. 7 square is 49 plus c. Now let us see one more type of problem in which we have the denominator as a quadratic polynomial, but it is not in the standard form. So we'll compare this with the standard form after completing the square method. Now let us try to make it into the standard form. We can easily see that we have x square minus 6x in the denominator. So to complete the square, we will add the square of half of the coefficient of x, that is minus 3 square, will be added and subtract from this whole polynomial. So this will be minus 3 square will be added and minus of 3 square will be subtracted from this polynomial to get the complete square, that x square minus 6x and minus of 3 square can be written as dx upon x minus 3 whole square plus we are left with 13 minus of 9. So we are left with dx upon x minus 3 whole square plus 4. Now we can compare this with the standard form after substituting x minus 3 as t. So let us substitute x minus 3 is equal to t. We get dx is equal to dt. So therefore the standard integral will be of the form dt upon t square plus 4, and 4 can be written as 2 square. Now this can be compared with the standard form 1 by x square plus a square, which is equal to 1 by a tan inverse x by a. So the answer would be 1 by a here is 2, tan inverse t by a. Now we'll re-put the value of t here to get the final answer, that is half tan inverse mod x minus 3 upon a is 2 plus c. Now in this problem you can see that there is dx by under root 9 minus 25x square. We don't have x square here, we have 25x square here. So we need to convert into the standard form by applying some standard substitution. So we can rearrange the terms and write 25x square as 5x whole square. Now we can substitute, we'll put 5x as t. So therefore the derivative of 5x is 5. So dx, 5 dx is equal to dt, means dx is equal to dt by 5. So after substituting these values, we get a standard form dt by under root 9 minus t square. So compare it with the standard form dx upon under root x square minus a square, or dx upon under root a square minus x square. We'll get the desired answer, that is sine inverse x by a, where x here is t, t by a. Now 9 can be written as 3 square. So we'll replace this 9 by 3 square. So t by 3 plus c. That means the desired answer is sine inverse t is 5x by 3 plus c. Now we'll encounter some problems where we have a linear polynomial in the numerator and a quadratic polynomial in the denominator. So what we will do here is we will put x minus 1 as a times the derivative of this denominator, that is a times d by dx of x square minus 1 plus b, where a and b are some constants. We are eager to find these constants a and b by comparing the coefficients of x and constant terms on both sides. Then we'll see how to solve this problem. Now we have left side as x minus 1 and right side as a 2x plus b. Now when we compare the coefficients, now we'll compare the coefficients of x and constant terms on both sides. Constant terms on both sides. What we get? We will get 1 is equal to 2a, because on the left side we have the coefficient of x as 1 and on the right side we have 2a as the coefficient of x. So we'll get the value of a as 1 by 2, and while comparing the coefficient of constant terms, or we can compare the constant terms, we get b is equal to -1. Now we'll rearrange these terms to form a new integral, that is a times derivative of denominator, that is 2x by under root x square minus 1 plus b times 1 by under root x square minus 1. So what we have done here is we have split this integral in two parts, I1 plus I2, where a and b are some constants. Now we'll solve these integrals I1 and I2. Now I1 can be solved where a was 1 by 2 and 2x by under root x square minus 1. That means we will substitute here x square minus 1 as t. So we get 2x dx is equal to dt. That means this will be reduced to a form dt by under root t. Now the standard integral can be followed here, that is 1 by 2 root t plus c. So the answer would be root t, where root of x square minus 1 will be the answer of I1 plus c. Now continuation. Now we'll solve I2 part. That I2 is b was -1, 1 by under root x square minus 1 dx. Now it is a standard form, dx by under root x square minus a square, which is equal to log of mod x plus under root x square minus a square plus c. Now we have solved both the integrals and we have let the constant of integration in both. So we'll write here the constant as c1. Continuation. Now the final answer would be I1 plus I2. We have solved the I1 part as under root of x square minus a square plus c we will write in the end, and the second part as minus log of mod x plus under root x square minus a square plus c1, and c will add up to form c2. Because in both the parts there was a constant of integration, we will write this constant of integration only once. So this is our final answer. Now let us see some more integrals. We have under root of x square minus 16. Now again this is a standard form. You can see the formula here, that under root of x square minus a square is equal to x by 2 under root x square minus a square, where a square is 16, minus a square by 2 minus a square by 2, that is 16 by 2 log of mod x plus under root x square minus a square plus c. So we have used the standard formula for this question. Now if the question is not in the standard form, then now we can see one more problem. Here we have to rearrange this to form a standard form. So what we'll do here is we'll rearrange the terms, that is under root of x square plus 4x. Now we will add the square of the half the coefficient of x and subtract it also. Now what we get is, we get under root of x plus 2 whole square, we get from there x plus 2 whole square and minus 4 plus 1 which is minus 3, and minus 3 can be written as minus of root 3 square. Now this can be comparable with the standard form under root x square minus a square, where x can be understood as x plus 2 and a can be taken as root 3. So the answer would be x plus 2 by 2 under root of x square minus a square. That means the whole term x square plus 4x plus 1 minus a square by 2. A is root 3. So root 3 square by 2 is minus 3 by 2. Log of mod x is x plus 2 and plus under root x square minus a square. That is x square plus 4x plus 1 plus c. So this is the final answer. Now in this problem we can see that the integral is of the form under root of quadratic, where in the quadratic we can see that the coefficient of x square is negative. So it will definitely be going to of the form a square minus x square. So let us rearrange and complete the square. We will rearrange these terms as 1 minus x square minus 3x. Now we'll add the coefficient square of the half of coefficient of x, that is 3 by 2 square we will add and 3 by 2 square we will subtract. That is, we will add and subtract 9 by 4 from this polynomial to rearrange and make it a complete square. That means we got 1 minus x minus 3 by 2 whole square. Now we are left with plus 9 by 4 here. So this will add up to become under root 1 plus 9 by 4, that is 13 by 4 minus x minus 3 by 2 whole square dx. Now we'll substitute x minus 3 by 2 as t, implies dx is equal to dt. So we got the standard integral here, that is under root of root 13 by 2 whole square minus t square dt. Now we'll use the standard form that under root a square minus x square is the standard integral, and we'll apply the formula and we'll also substitute the value of t in the final answer. So under root a square minus x square is x by 2. So that would be t by 2 here, but we'll put the value of t as x minus 3 by 2 upon 2 under root a square minus x square, which will going to be, the actual question was 1 plus 3x minus x square plus a square by 2, that is 13 by 2 into 4 sine inverse x minus 3 by 2 by under root 13 by 2 plus c. Now which can be written as 2x minus 3 by 4 under root 1 plus 3x minus x square plus 13 by 8 sine inverse, we'll take the LCM here, 2x minus 3 by root 13 plus c, which is our final answer. Now let us solve one more problem. We have under root of x square minus 8x plus 7. Now you have understood that what we are doing, we are completing the square here. That means minus 8x is there. So we'll add 4 square and minus 4 square plus 7 to complete the square. We got the standard form, that is under root x minus 4 whole square plus 7 minus 16, which is of the standard form x minus 4 whole square minus 9, and 9 can be written as 3 square. So this is the standard form under root x square minus a square. We will substitute x minus 4 as t to get the standard form under root t square minus 3 square. That means dx was replaced with dt dx was replaced with dt, and the standard form is comparable with the standard under root x square minus a square. Now, while putting back in the formula, we'll put t as x minus 4. So, we'll get the standard form as x minus 4 by 2 under root x square minus a square, that means x square minus 8x plus 7, because while we resolve x square minus a square back, we'll get only this, which was the present in question. Now, it will be a square by 2, that means 9 by 2 log of mod x was x minus 4 here, plus under root x square minus a square, and x square minus 8x plus 7 plus c, which is our final answer. Now, in this problem, we can see that we can replace x by 3 as t, or we can directly take the LCM here inside the root. What we'll get here is 9 plus x square divided by 9 dx, which can be written as 1 by 3 integral of under root 9 plus x square, which is a standard form under root a square x square plus a square, which is equal to x by 2, that is 1 by 3 was already there, so which was x by 2 under root x square plus a square was 9, plus a square by 2, because a was 3, so a square is 9 by 2 log of mod x plus under root x square plus 9, which is our answer. Dear students, today we have done some integrals based on standard integrals. We have covered standard integrals of the form linear by root of quadratic, linear by quadratic, and 1 by quadratic. And also we have covered standard integrals of the form under root of quadratic and simply quadratic. So, in the next lecture, we are going to do the remaining part of the definite and indefinite integrals. Thank you.